Hey guys, Miss Smith here. So today we're going to be looking at evaluating more definite integrals, but now we're going to be looking at definite integrals that involve trig functions, including U substitution. You may want to get your multi-view calculator out and handy, and while you're doing that, also put that calculator in radian mode because we need that specifically for trig. All right, let's get started. Okay, so as we said, we're doing definite integrals involving trig functions today. So starting off with the definite integral from 0 to pi of sine x dx. Okay, so the procedure is not any different from what we've done with other definite integrals in the past. This one does not necessarily, well, it doesn't need to use substitution at all, really. We just need to do the antiderivative, which would be, now careful with this, negative cosine x, right? Because if we take the derivative of cosine, the positive negative SIGN changes. So we need to have negative cosine for that antiderivative. Okay, so then I'm going to have negative cosine of pi minus negative cosine of 0. Okay, now at this point, we are okay with you using the multi-view calculator to figure out cosine pi, cosine 0, but a few things moving forward. First of all, I am going to show you how to remember how to do that by hand based off the unit circle methods that we have talked about in class previously in the past. But also, when we look at other types of functions, so like when we do these with cosecants in a moment and whatnot, obviously your calculator only has buttons for sine, cosine, and tangent, so you will have to know at least enough basic trig and reciprocal identities to be able to deal with that. So obviously right now for a cosine, that's not an issue. Okay, so negative cosine of pi, so just as a quick little reminder over here about the unit circle, if we are at pi, then we are over here on the left side of the x-axis. That means that I am at ordered pair negative 1, 0 because I have gone left, but I have not gone up. And cosine and sine, cosine is the x. So cosine of pi is negative 1. So this is negative, negative 1 minus cosine of 0. Okay, so same thing. 0 is on the right side of the unit circle where I have gone over 1, up 0. Cosine is the x. So that is negative, because it's negative cosine 0, 1. Okay, so from that, we get positive 1 plus 1. So this definite integral equals 2. Okay, and again, yes, if you just use the calculator on this, that's fine. So for that part anyway. Okay, so now we're going to look at the definite integral from negative 3 pi over 4 to 0 of negative cosine x dx. So again, don't assume everything needs U sub, it doesn't. U sub is only if we have a chain, and this is just negative cosine x. That's not a chain. There's only an x on the inside. So we're not U subbing this, we're just doing the antiderivative. Okay, so negative cosine is the derivative of negative sine. So just negative sine of x from negative 3 pi over 4 to 0. Okay, so then that means that we're going to have negative sine of 0 minus negative sine of negative 3 pi over 4. Okay, well first of all I have a minus and negative there in the middle, so I can make those positive. But okay, let's see. Sine of 0, well, at 0 I am at ordered pair 1, 0, and the sign is the y, so that's 0. That's nice. Okay, now negative 3 pi over 4. So negative means that we are counting that angle backwards, right? That we are going the other direction. So 3/4 of pi. Okay, so if I go to half pi and then I go another fourth, that puts me down here in quadrant 3. Okay, now if we think about regular pi over 4 up here, where we are at root 2 over 2, root 2 over 2, then down here in quadrant 3, everything is negative, and so the sign of negative 3 pi over 4 is going to be negative root 2 over 2. And since it's 0 plus that negative, that's it. That's the answer. It's just negative root 2 over 2. Again, if you are in radian mode with your multi-view, you're welcome to do that. All right, getting a little more complicated, right? That's what we do. This is math class. Okay, so we've got the definite integral from negative 3 pi over 4 to negative pi over 2 of negative cosecant squared x dx. Okay. Cosecant squared comes from cotangent, right? So remember that if we have derivative of tangent, it is secant squared. So then likewise, if I have derivative of cotangent x, that is negative cosecant squared x. So since this is negative cosecant squared x, my antiderivative is positive cotangent of x. Okay, now since this is not a sine, cosine, or regular tangent, we're going to have to do a little bit more thinking when we do our f of b minus f of a in order to even to be able to use the calculator, right? So we're going to have cotangent of negative pi over 2 minus cotangent of negative 3 pi over 4. Okay, now we can navigate the unit circle, or we can try to navigate the calculator. But sometimes doing it on the calculator won't work because of domain issues. So first of all, keep in mind the reciprocal identity that cotangent is the reciprocal of tangent x. Okay. So if we're trying to figure out the cotangent of negative pi over 2, right? And cotangent is also, since it's the reciprocal of tangent, it is also cosine over sine. Okay, so we're thinking in terms of the unit circle for negative pi over 2. Again, negative angles mean that we are going backwards, right? So down here at negative pi over 2, so that means that I have gone down 1 unit, right? So that it's 0, negative 1, cosine, sine. Okay, so that means that the cotangent of negative pi over 2 is the cosine over the sine of negative pi over 2, which is 0 over negative 1, which is 0. If you had tried to do that in the calculator using the tangent function and you said 1 over tangent x, it actually will give you a domain error. I can't show you that in this current software that I'm using to record, but if you try that, it does give you a domain error because the tangent of negative pi over 2 is undefined because of that 0. Right? Tangent of negative pi over 2 is 1 over 0, which is undefined. So the calculator actually can't deal with that unless you do cosine and sine separately. So if ever you're doing tangent, cotangent stuff in the calculator and you get something undefined, some 0 is happening somewhere. So go back to thinking of it as terms of sine and cosine and try to figure it out that way. So in order to be able to figure that out, you do have to understand it beyond just mashing buttons in the calculator. But then we have minus the cotangent of negative 3 pi over 4. We actually just did a little negative 3 pi over 4 in the previous problem, right? It's down here. Negative root 2 over 2 or negative root 2 over 2. Well, okay then. So that means that the cotangent, which is the cosine over the sine, is 1, right? Because those are both the same. So that this whole thing, just 0 minus 1, is negative 1. All right. All right, now this is actually going to require a little bit of u-sub on this next example. We have the definite integral from pi over 3 to pi of negative tangent x secant squared x dx. Now, secant squared x tangent x is not a derivative of anything. And there's actually a couple different ways you could do this because the derivative of secant is secant tangent, but then also the derivative of tangent is secant squared. And that latter one is the one that I'm going to use. But there's actually, because of the wonders of trig, there's actually two different ways you could do this. But I'm going to let u equal this tangent x here, okay? Because if I let u equal the tangent of x, then the derivative of that for my differential, derivative of tangent x is going to be secant squared x dx, which is perfect because it's right here. Ta-da! Okay. Now, remember that if we were doing a definite integral with u sub, as we've discussed in a previous video, that you want to take it one step further, and however you defined your u function to whatever that equals, that you are going to be changing your boundaries, right? So you're going to change that pi over 3 and that pi, and you're going to do that by taking both of them and plugging them in to u, right? We're treating it like it's an f of x, and we're taking those and plugging them in. So we're going to do tangent of pi over 3 and the tangent of pi. Okay, now a little bit of unit circle. Tangent of pi over 3. Pi over 3 is 1/3, which if we're counting in a positive direction from 0 is right about up here, right? And if we're thinking about where that is, we know that, okay, you've got a pi over 6, you've got a pi over 4, and then you've got a pi over 3. And at pi over 3, my y-coordinate is larger than my x because I have gone only a little bit to the right, but I've gone a bit farther up. So my x is less than my y, right? Root 3 is greater than 1. So there's my cosine and my sine. And for tangent pi over 3, tangent is sine over cosine. So it is root 3 over 2 over 1/2, which is root 3, right? It's like the halves cancel out, and then we just have root 3 over 1. Tangent of pi for my upper boundary. Okay, so pi is over here. I've gone left 1, up 0. Sine over cosine is 0 over -1, so it's 0. Okay, so I have changed the a and the b, right? The pi over 3 and the pi have new identities, right? Witness protection. And u is tangent x, du is secant squared x dx. Okay, now we're ready to substitute everything. So pi over 3 becomes root 3 based on substitution that we've prepared over here. Pi becomes 0, again based on what we've done over here. Let's see, there's a negative because it was just there. Tangent x is getting replaced with u, and secant squared x dx, all of that is getting replaced with du. Okay, so what does that mean moving forward? What it means moving forward is this problem just got a lot easier because guess what? There's no more trig left on this problem. We already did it. We changed our limits a and b, and because we did that, now we're done with all that tangent stuff. It's gone. Let me show you what I mean. So we have this negative u in our integrand. Okay, so we're going to do the power rule with that, and we're going to go up to the second power, like so. Right, increase the power by 1, divide by the new power, and then because I don't go back to x when I'm doing a u sub with the definite integral, because this root 3 and this 0, those are u values, right? And I need to plug u into u, so I'm going to leave the -1/2 over here and just do 0 squared minus root 3 squared, right? Because that coefficient is only applying to a single term, so we can do that. Yeah, I've got -1/2 times okay, root 3 squared is 3. Cool. Negatives cancel. It's 3 over 2. So this is where changing the a and the b like really comes in super, super handy, is the fact that what that means is that we don't have to go back to tangent, right? That once we've taken care of all of that stuff up here in the beginning, right, and all that unit circle nonsense, we're done. If that's not part of our substitution, we don't have to revisit that part of the problem. By changing that pi over 3 and that pi at the beginning, we're done with the trig. So that's really nice. It's not necessarily going to happen on every problem, but if you're dealing with u sub, that means you have two different types of functions happening at the same time, right? You've got an inside and an outside. And so if you deal with one of those at the beginning, what's nice in a definite integral is you don't have to come back to it at the end. It's just done. So yeah, that's nice. All right, so here we have the definite integral from 0 to pi over 2 of sine x times root cosine x dx. Okay, so again, there's a lot of stuff happening, but I see a root with a cosine in it, right? Those two things don't go together. That's a chain. So we're going to let u be our placeholder for cosine x. And the reason that works is because on the outside there's that sine x dx. So my du, derivative of cosine, is negative sine x dx. Right? And we don't have a negative, so we'll just say that negative du is sine x dx. Right? And then we're ready to substitute for all of the x's and the differential dx. But I want to take those limits, the 0 and the pi over 2, and I'm going to change those. So we do that by taking them and plugging them into u, which is cosine x. So we're going to do cosine 0 and cosine pi over 2. Okay? And again, my quick little unit circle doodle here. So if we are at 0, we've gone over 1, up 0. And if we are at pi over 2, we have gone over 0, up 1. Cosines are the x's. So cosine of 0 is 1. And cosine of pi over 2 is 0. So with that, I've changed the a and the b, I've changed the u, I've changed the du. Now we are ready to go. 0 on the bottom is turning into a 1 based on our substitution up here. Pi over 2 is turning into 0. Okay. The sine x and the dx are both going to turn into a negative du. And then we've got root cosine x. Okay, so that's root u, which we know is about to turn into a u to the 1/2 power. Okay. All right. So for the power rule, right, we've got a 1/2. So if we add 1, that becomes the 3/2. Put a reciprocal in front of that. 1 to 0. And then we are going to substitute, right? But again, as we've said before, anytime you've got one of those unusual powers in here, before you substitute, you may just want to do a quick rewrite to make it be a root again, right? So this would be the square root of u cubed. The denominator is the type of root, and it always goes back to the type of root it was before, right? If it was a square root, it will still be a square root, just with the different power on it. But I'm going to put that negative 2/3 out in the front, and then I'm going to have root 0 cubed minus root 1 cubed. And man, 0 and 1 aren't they just the best? They're just so easy because their powers are easy peasy, because this is just negative 2/3 times 0 minus 1. So it's just negative 2/3 times negative 1, which is positive 2/3. All right, so I think we have time for one more if we go quickly. Okay. All right, so the definite integral from 0 to pi over 12 of 4 secant 4x tangent 4x dx. Okay, that pi over 12 is kind of a hint, right? That's not on the unit circle, so we are not going to be taking pi over 12 to the unit circle, but what we are going to be doing is a little bit of u sub. Notice both this secant and this tangent have a 4x on the inside. All right, so we're going to let u be that. We're going to let u be 4x, so that du is 4 dx, and we actually have that 4 on the outside this time. It's right here, 4 dx. So that's great. Cool. With that 4x, we are also going to be changing our limits. We're going to do a u of 0 and a u of pi over 12. So 4x for both of those. And obviously the 0 goes to 0, and 4 times pi over 12, okay, so that's going to be pi over 3, which is a much more normal thing to be working with, right? Pi over 3. Okay, well, we know that. We've seen that. It's on the unit circle. No biggie. All right, so we are ready to substitute. So the 0 is turning into a 0. The pi over 12 is turning into a pi over 3. The 4 and the dx are both turning into a du, so that 4 in the front is gone. And this becomes secant u tangent u for our integrand. Secant u tangent u. Okay. All right, well, secant, tangent together is the derivative of secant. So my antiderivative is just secant u, because the derivative of secant is secant tangent. Okay, so this means we're evaluating secant of u from 0 to pi over 3. So we're going to do secant pi over 3 minus secant of 0. Okay, now, unit circle, briefly. First of all, secant is the reciprocal of cosine. Okay, so if we are mashing buttons on the calculator, cosine is where you're going to need to go for your secant. So don't get that confused. Secants go with cosines, and cosecants go with sines. Those are reciprocals. Okay, pi over 3, which we did in a previous problem. Pi over 3 is right here, right, just shy of pi over 2. It's 1/3 of pi. So that's 1/2 root 3 over 2, because again, the y-coordinate is larger. For secant, what matters is that cosine, right? So secant of pi over 3 is 1 over 1/2, which is 2, right? It's the reciprocal of 1/2, and flip it, and it's 2. So secant of pi over 3 is 2, minus secant of 0. Okay, so it's 0. We are at ordered pair 1, 0. The cosine is 1, and the reciprocal of 1 is 1. So 2 minus 1 is 1. All right, so that's your guided tour of definite integrals with trig functions, sometimes involving u substitution. We did skip over a few examples, kind of like the previous one. That I skipped over a few of them in the interest of time, trying to keep these in the ballpark of 20 to 30 minutes, so I don't want to keep talking. But again, just like before, the PDF with the filled in version of any examples that we didn't have time for in the video, those will be on It's Learning. And as always, we encourage you to ask questions about any of those if you see them and can't quite figure out how something went. But yeah, that's it. Thank you for watching, and bye.